Hello everyone. Hope you guys are doing great. As you guys can see my thumbnail, today we are going to discuss about a text classification with one of the very trending framework, I could say. Just a framework. Not an algorithm, but I believe this is the game changer of any kind of language model like BERT, RoBERTa, and any kind of large language model you can say like GPT as well. So I can show you the metrics as well. I will show you in this video at the end of the metric what are the how I am able to say like this SetFit model is better than the any kind of large language model. So without getting delay, let's begin our topic. What we have to discuss. So I set an agenda. If you can see what are the things we are going to discuss. First we'll go with the introduction, then I will also walk you through the research paper, and then third thing will be why SetFit, and framework walkthrough I will give, and then we can discuss. If there is any question, then we can go through that question. Otherwise, feel free to put a comment of the video, right? So first thing is that why we propose SetFit. Okay, nowadays like chat gpt is very trending in the market. Like many people are using those things. I believe that I also used, but there is just some certain task like some text classification which is very common, very common in any kind of language problem like natural language processing, right? So there the thing is that if you are going to start using this kind of thing also with the chat, it's a very costlier process, right? And again, the accuracy bias, I know ChatGPT stands always better because it's a huge data and a lot of guidance are there. So there is a problem in the any kind of, we can use our own language model, that is also fine. The problem with the language model, number one, it's a very huge size, hard to deploy. Second thing is that if you are using any kind of language model like large language model, especially I'm talking about the large language model like Fluent T5 or ChatGPT, whatever it is, we used to do the prompting, right? We used to have to provide the prompt and then we have to pass the task. So here is the two thing is going to be happen. Like one is task classification. Second thing is how to perform. One, as soon as, let's suppose, summarize this conversation, classify this text with positive and negative sentiment. So first of all, it is getting identify the prompt, what the prompt is saying, and then it is performing the certain task, right? So there is a two thing. That's a, like a huge means it's a very costlier process, right? Second thing is that if you're using any kind of state of art algorithm like BERT, RoBERTa or kind of thing, right? That's a base model we are using. On top of that, we are going to apply the classification head, right? So for performing the down the line task. So this is again needed a huge amount of data to accomplish some certain task. So in order to overcome this kind of problem, so we have seen in SOTA, we need a huge amount of data. Second thing is that in case of language model, you could say, why cannot we use the language model? I would say, yes, you can use, but again, it's a costlier process, right? So we have seen accuracy bias. Number one, if you are going to fine tune any kind of state of art model like so BERT or RoBERTa, whatever it is, we need the data size. You can see in the left side section how much data we need for the set fit for any kind of text classification. Let's suppose there is a 2 classes or 3 or 10 classes. Each classes at least we have 20 to 25 utterances. Then your model will be at least, you can say, it's at good position, right? But if you can see set fit, we need 375x lesser data to train our classification model. That's a huge gap it is. Similarly, if you can see the accuracy bias, what is the difference here? See, you are using 375 of data, more 375x more data for fine tuning the SOTA algorithm. You are getting 94% accuracy. But let's suppose if you are using the set fit and you are using only 32, means 375 lesser data, then you can see just how much compromise you have to do with your accuracy point of view. 7%, just 7%, right? So it's a huge gap between these two things, right? So that's what that's what it's SetFit is very trending. And now the thing is that how it is performing these things, how it is able to do these things, right? We can walk you through. Before that, just I wanted to give you the quick recap how the SetFit is working. I means like how the state of art models are working. First of all, as soon as we are giving any kind of utterances, then on top of utterances, BERT layer is there, any kind of model, state of art model, language model, you can say, for example, BERT. And then it is applying like classifier. Okay, neural network will do the classification and it will give the churn probability and will give the probability out of that. Okay, so it will try to classify this thing. This is the conventional state of art model algorithm works, right? Now let's suppose if you are using the SetFit, then we need very less amount of data to train these things. First thing is that its second thing is that it's very means fast to execute the thing, very less resources we need. Okay, now how it is working, let me explain these things with this diagram. So SetFit thing, complete SetFit framework having the two part. One, you can see this sentence transformer fine tuning, and second is that classification head. Sentence transform fine tuning, how it works. So, it use internally contrastive learning. I will talk about this. What is the contrastive learning? It is, so let's suppose if you are giving two sentence, I love you, I hate you. There's a one thing is that positive and one is negative sentiment. Just for example, I'm saying. So what SetFit does is the sentence transform fine tune. It create a different variety of the sentence with these things, and which is very similar to the utterances what you provided for the training, and it generate internally huge amount of data. And then on top of that, it is applying the contrastive learning. And how it is going to calculate the means how, what is the contrastive learning? So let's suppose there is a two sentence, I love the family plan and total rip off. There is a and third sentence is coming, great reception. So how it is going to perform here, like it's calculate the distance. You can use any kind of distance formula, Euclidean distance, whatever things is there. So you can calculate distance formula, and based on the distance, what it does, it find it out what is the closest sentence, it fall in that, right? And then same thing, it perform like it's a generated a sentence, and then on top of that it apply the classification, right? And it perform the classification, right? So let me talk about now, let me walk you through, guys, the research paper as well. um okay, so I think this is the research paper which I was talking about. So you can see recent few short methods such as the parameter efficient fine tuning, which is abbreviated as a PEFT, and pattern exploiting training have achieved impressive result in the label stress setting. And however, they are difficult to employ since they are subject to high variability from the manually crafted prompt, right? And typical require billions of parameter language model, billions of parameters language model to achieve the high accuracy. As I told, like if it is any kind of language model you are using, like chat GPT or Clone T5 XL XXL, first thing is that we need very huge, means two tasks we are performing. Here is only the cost is there, right? And the SetFit is the prompt free generative framework, like it generate a sentence with similar kind of matching. Let's suppose you, as I given the example, right? And then it does everything, and you can see the accuracy wise, it's quite well accuracy as compared if you are comparing with the RoBERTa. And I have not evaluated this model, but I did one experiment and it performed very well, outstanding. And I compared with that this model with the BERT, and it seems like it's really awesome result it is. Now I can come up with some pointers. So we propose SetFit is a simple prompt free. That's the first thing. Second thing is that we evaluate SetFit performance on the number of few short text classification tasks, shows that it outperform state of art model or prompt free method anymore, right? And we make, means like the code base is already available. And also I just this is the this things I already explained there. And how the SetFit is working, it use the contrastive learning. As I told, contrastive learning is what? It's just a distance calculation formula. Like whenever the sentence is getting generated, so it use contrastive learning and calculate the distance between your real sentence and the generated sentence, and wherever it fall, it full put in that, like this is called contrastive learning. You can see this also, they have shown that. And best part, what I understood, I have seen there one evaluation metric. Okay, so these are the three experiments they have been done. One is each, en and all. Each means train and evaluate on monolingual data. Monolingual means like either English, French, Germany kind of thing. And measure the per language performance, means train on English, measure the performance on English language only. Train on French, measure the performance on the French language. And English means train on English and evaluate each language test set, means train on English and evaluate on French, English, Germany, everything. All means train on all training data, evaluate on each language test set. So this is the three experiment they have been done. And if you can see the result, I would show you. Yeah, this was the result. This is the result. You can see the result. Like n is what? N is means like each class. There is, let's suppose there is text classification, multi-class classification problem. Two classes there. Each class there is an eight subset. Similarly, 64 subset, and similarly they haven't taken the full subset. And the result is quite impressive. And also they have shown the memory utilization somewhere. You can see, yeah. So you can see for the SetFit, the flops. So flops is basically very high, and train flops is also high. And speed, you can see 19x faster than the any kind of 3 billion language parameter. It is a language model, large language model. It's a 19x faster. Similarly, SetFit, another variant is there, 123x faster. So yeah, this is very pretty much clear to understand all the sort of things. I believe I'll show you the actual implementation, how we can implement the SetFit to perform any kind of text classification, right? Hope you guys understood this concept. And if you guys having any questions, any thoughts around it, feel free, put over the comments. I'll be happy to address these things. Thank you. We'll catch in the next video with the implementation.